Okay, so the second part of the week 7 tutorial is about the conservation of energy. You remember that the first part was about the energy and work, and now we're going to talk about the conservation of the energy for the planar kinetics of the rigid bodies. So we start with the first example we're going to have here, which is going to be about a ball, a solid ball of 2 kilogram mass. It's released from the rest when the theta was 30 degree. So theta was 30 degree. It was at rest, that means the omega was 0. We need to remind what will be the angular velocity when the theta is going to be equal to 0. So it's going to reach the bottom of the curve. The ball does not slip as it's going to be rolled. So that will be the two states. The state number 1 when it was at the height 1, and then it's going to go to the height 0. We are going to consider that the second position is going to be the datum point, and the other one is going to be, well, I'm going to show you actually how this one calculated. This is 1.4, okay? And we are going to check what will be the height here. So again, once again, this will be 1.4 because this is radius. So the height here is going to be equal to 1.4 multiplied by cosine of 30. So to find the height, again, to substitute the 1.4 minus 1.4 cosine of 30. We're going to come to this one very soon. So the solution tell me is that we need to establish the datum point at the lowest point, and for the ball, the Ig value is 2 over 5 mass r squared. Since there's no slipping, so the Vg is going to be equal to 0.1 omega, which is the radius of the ball multiplied by the omega. The equation we're going to use is going to be the energy conservation equation. The T1 plus the V2 is equal to T2 plus the V2. T1 plus V1 equal to T2 plus V2. We will find that the answer is going to say that the omega is equal to 16.2 radian per second. So we start first with the free body diagram. This was the first position of the ball, and this will be the second position. So now the height from the origin to this height here. Let me actually use my pointer again. So the height from this point to here is 1.4 cosine of theta. Well, the total height is 1.4, so we can find the difference between these two positions. In this position, we are going to have the weight going down, and we are going to have the friction force going upward. The normal force is going to go perpendicular to the friction force. And this will be second position. The datum point is going to be where the height is going to be equal to 0. And we know that theta 1 is equal to 30 degrees, theta 2 is 0, omega 1 is 0, and the mass is 2 kilograms. The unknown is the omega 2. So the equation we're going to use, we are rolling without slipping. And this will cause the static friction between the ball and the track, and the friction force does not work. So we're almost going to consider that this value to be equal to 0. So only the conservative force is going to be gravity force does the work. It's going to be the weight negative weight multiplied by the delta y. So the conservation of energy will tell me that the T1 plus the V1 equal to T2 plus the V2. Now, once again, solution starts with finding the Ig for the ball. So it's going to be equal to 2 over 5 mass multiplied by the R of the ball square. And we will find that by substituting the value for the R to be equal to 0.1 meters, and the value for the mass is 2 kilograms. And by putting that together in the equation, we'll find the value for the Ig to be 0.008 or 18 thousandths kilogram meter square. Now that will be the equation we're going to use. And with ball rolls without slipping, the velocity is going to be equal to the omega multiplied by the R, or equal to 0.1 omega. So if I get to multiply, choose this velocity to be replaced with this equation here, I will rewrite down the equation in terms of the omega. Now we're going to start to do the calculation. Once again, I'm going to take this equation to the other slide. So that's the equation, and we can calculate the T1 now. T1, by replacing the omega equal to 0, I'll find that the T1 is going to be equal to 0, while the T2 is going to be in terms of the omega 2, which I don't know how much. So this will be 0, this one will be replaced by the omega 2, and this one to by the value of 0.1, and start to open the brackets. So I'm going to come to this value, then I will find that the T2 is equal to 0.014 omega 2 square. Now, I found the T1 and the T2. Now I need to find the V1 and the V2. So we said that this work is going to be done mainly due to the weight and the height. So again, to write down the equation for the V1, V1 is equal to the weight multiplied by the Y1. And we said that the Y1 is equal to 1.4 minus the 1.4 cosine of 30. So the mass is 2 multiplied by 9.81 multiplied by that height, and this will be equal to 3.68 joule. Now we're going to repeat the same thing for the second position, and we're going to find that the value is going to be equal to 0 because the height 2 is equal to 0. That's it. I have the T1, T2, V1, V2. I can put that in my equation, and I will find the value of the omega 2. So the omega 2 is going to be equal to 3.68 divided by 0.014 under square root, and this will give me 16.2 radian per second. That's it. Okay, so we just need to think about the situation logically, try to find the positions, try to find the equation, apply it, and we're going to find the answer for the omega.